Hello everyone, and welcome to the next video on the topic of conversions between percentages, fractions and decimals. In this video my focus will be on conversions from fractions to decimals and also from decimals to fractions. And in the next two videos I will be talking about conversions between fractions and percentage and vice versa, and also conversions between decimals and percentage and vice versa. All right, so for the topic today, which is conversions between fractions and decimals, we begin by talking about how we go from fractions to decimals. And the question of how it's done, basically you divide the numerator of the fraction by the denominator of the fraction. As an example of that, let's take a look at 1/2. Now I know that you're probably quite familiar with how 1/2 converts into a decimal, but keep in mind we're just getting practice here so that when numbers are not so easy to work with, we know what to do. So again, in case you know it, and you should say 1/2 is 0.5 or 5/10. But the way to work it out is to do a long division. We divide 1 by 2, and here's the long division that I've set up on the right side here. We are dividing 1 by 2, and the question now is how many 2's fit into a 1, and the answer is 0. So we put down 0 at the top, and I'm going to take shortcuts now in doing long division, because otherwise it can become a little bit too long. The writing of it becomes too long, and I also recommend that you sort of try to learn these shortcuts. They are really good shortcuts. So 2 goes into 1 0 times, and one shortcut is that if you happen to come up with a 0 at the top, you don't really have to multiply it by 2 and write it down and subtract, because that's not going to change the 1. So we just keep that in mind, and then we notice that now we have a decimal point. That's important, and that decimal point will be carried to the top. So my next image is that I have the decimal point up here. I didn't bother to write it down here because all I care about that is that it's going to be moved up to the top. And now we add a 0. Another question is how many 2's into 10? How many 2's fit into 10? And the answer is 5 of them. We multiply 5 by 2 to get 10, write it down, and then we subtract. And that gives us 0. So 1/2, 1 divided by 2 gives us 0.5 or 5/10. And that's what we write now over here. We have 1/2 is equal to 5/10. Yeah, you notice that it does make sense. 1 out of 2 is the same as 5 out of 10. You also notice that what I said in the previous video, you can actually see that 1/2 divides 1 into 2 parts, but a decimal does not allow division into 2 parts. It only allows divisions into 10 parts or 100 parts or 1,000 parts and so on. And here we find that by the time we deal with the tenths, we've arrived at the value that 1/2 sort of refers to. We get 5 pieces out of 10 pieces, 5/10. Okay, problem number 2, 3/4, and again this is one of the ones that you should know by heart. You shouldn't have to really do a long division to figure out that 3/4 is 0.75. But again, to get some practice, let's take a look at the division. So we divide 3 by 4 now. 4 into 3 goes 0 times. Now we put the decimal point, add a 0. 4 into 30, 7 times. 7 times 4 is 28. Subtract. Okay, now again at this stage we would add a 0 up here and pull it down, but the only reason we put it up here is as a reminder that that's a 0 past the decimal point over here. And the idea is that eventually we want to pull it down. So the shortcut here is if you need to add a 0, you don't have to really write it down up there. You can just pull it down and put it down next to the 2, like this. Now we have 4 into 20, and that goes in 5 times. 5 times 4 is 20. We subtract, and we're done. So 3/4 turns into 0.75 or 75 hundredths. Okay, problem number 3. Now, one thing that you notice about problems 1 and 2 is that the fractions that we had, 1/2 and 3/4, both of them are proper fractions. Size-wise, their sizes are less than 1. You can just visualize 1/2 is less than 1 and 3/4 is less than 1. And you notice that the decimal equivalent has a 0 as a whole part, right? If you have an improper fraction, like 5/4, then the whole part will not be 0 because 5/4 is more than 1. An improper fraction is either equal to 1, that's when you have something like 4/4 or 3/3 or 10/10, or it's more than 1. And in any case, whether it's equal to 1 or more than 1, that means that the whole part of the decimal number that's coming out will not be 0. That's a good thing to know because ahead of time it gives you sort of like an expectation, an understanding of what to expect. So 5/4 will have something other than 0 on the whole side of the decimal. Okay, let's take a look at the division by 5 by 4. Now you see 4 goes into 5 once, and then 1/4 is 4. Subtract, we get 1. Now we have a decimal point, and I'm just going to move it up and put it up here. And then we would add a 0 and pull it down. And I'm just going to put it down here. 4 into 10, twice. 2 times 4 is 8. And then subtract. Now again, we would add a 0 and pull it down. And I'm just going to take the shortcut and put a 0 down here. My apologies, there we go. And then 4 into 20, 5 times. 5 4 is 20, subtract, and we get 0. So as you can see, we end up with 1.25, or 1 and 25 hundredths. Okay, problem number 4. Here we have another improper fraction, and this one I'm going to leave it to you to do the long division. If you like, you can pause the video and do the division. A bit of practice every now and then is helpful. Then once you're done, you can take a look at the answer, and it should turn out to be 2.75 or 2 and 75 hundredths. Problem number 5. Sometimes there will be no decimal digits, or they will all be 0. If we try 8/4, we would divide 8 by 4, and that would give us just a 2. And of course, you may end up with 1, such as in 3/3. If we divide 3 by 3, we get 1. So these are 2 examples when you don't have to go into decimal digits, because the division ends by the time we get to the decimal point. Okay, problem 7, 3 and 2/5. Now to convert this into a decimal, the best thing to do is to write the whole part, which is 3, on the whole side of the decimal. So we put down 3 point. And then for the fractional part, which is the right side of the decimal point, we divide 2 by 5. Here's the division. 5 into 2 goes 0 times. We put the decimal point, add a 0. 5 into 20, 4 times. 4 times 5 is 20. Subtract. And we're done. So 2/5 turns out to be 4/10, 0.4. And this decimal digit 4 will be what we need here. So we'll end up with 3.4. So you can see on the left we have 3 and an additional 2/5. On the right side we have 3 and an additional 4/10. Now this approach is much better than turning 3 and 2/5 into an improper fraction. So in that case you would get 5 times 3, 15, plus 2, 17. And you would put down 17/5, and then dividing 17 by 5, because you're going to end up with 3.4. And the thing is that you'll do a lot more work, especially when the whole side is a larger number. and this one can be instructive. Let's take a look at, instead of 3 2/5, let's take a look at 107 2/5. Following the approach that we just talked about, we put down 107 on the whole side of the decimal, so we end up with 107 point, and then we divide 2 by 5 the way we did over here to get 0.4, and the 4 will appear here, so we end up with 107.4. And the work that we had to do that took a bit of time was, of course, the division of 2 by 5. But as you can see, it's not a huge division. Like, it's not that difficult to finish it relatively quickly. Now, if you convert this into an improper fraction, then your 107 2/5 will turn into 537 fifths. Now you will have to, instead of dividing 2 by 5, you have to divide 537 by 5. And you will end up with 107.4 in the end. So a lot of the work has been, it was unnecessary, if you like. Now I was going to let you do that division, but I think in order to show you how the 107 will come out, it's actually nice to take a look at this division. 537 divided by 5. We begin with 5. 5 into 5 goes once. 1 5 is 5, subtract, and then 3 comes down. 5 into 3 goes 0 times. Now if it's a 0, I'm not going to bother 0 times 5, 0, and subtract. Again, I'm going to take the shortcut and bring 7 down. 5 into 37 goes 7 times. 7 times 5 is 35, and we subtract to get 2. Okay, let's pause for a minute and see what happened. As you can see, the 107 came out. This is the 107 on the whole side. And now the rest of it is divide 2 by 5, which is what we did here. So all of this work, going from 107 2/5 to 537 fifths, doing all of that work, and then all of the work that you see up until here were totally not needed. These are extra steps that we took that brought us back to exactly where we were here, 107, and then divide just 2 by 5. To continue now, we have a decimal point. We add a 0, and then 5 into 20 goes 4 times. And there you have it. Okay, so we end up with the same value, 107.4. Okay, now that we have talked about how to go from fractions to decimals, let's go the other way. We want to convert decimals to fractions. I guess I need a plural S there. All right. Okay, so what we have next is the question of how we do that. You know, it's actually pretty interesting that you can actually read the decimal formally, and it just will tell you what the fraction equivalent is. To show you an example of that, let's say we have 0.3. Now, if I read this formally, and instead of 0.3, if I say 3/10, then that's exactly what the fraction sounds like, 3/10. See, this is why it's good to know how to read these numbers, or one reason why it's good to know how to read these numbers formally. So here you have 3/10, and here you also have 3/10 written using two different notations. Of course, there is also the approach that says that the number of zeros in the denominator will be the same as the number of decimal digits that you have in the decimal representation of the number. So if you have one decimal digit, you will get 10. 1 0. If you have two decimal digits, such as it would have been the case if you had something like 0.35, then you would have 100 down here. But I still think going with the formal way of reading it is much neater. It also helps you make a connection. Okay, number 2. 0.41. Now this one has, you can go by the argument that this one has two decimal digits, so we end up with 100 in the denominator, and we get 41 over 100. Or you can just say the formal reading of this is 41 hundredths, and then that tells you how to write the fraction, 41 hundredths. Problem number 3, 0.125. The formal reading of this is 125 thousandths. So we get 125 over 1,000. Now sometimes you might be able to reduce your fraction, of course, and this is the case for 125 thousandths. You can reduce, try to reduce in one step. There is nothing wrong with taking multiple steps to reduce. As I've said in the section or in the videos on fractions, doing this in one step is of course neat, and it appears to be shorter, except that finding the largest number that goes into the top and the bottom is somewhat of a challenge more often than not. But if you divide by smaller numbers, you will do multiple divisions, but because the numbers that you're dividing by is smaller, makes the divisions easier. I'm going to do this in multiple steps. Starting with 5, I can see that 5 goes into both the top and the bottom because the top ends in 5 and the bottom ends in 0. Dividing the top by 5, we end up with 25, and dividing the bottom by 5 gives us 200. And once again, we notice that we can use 5 again. Because 25 ends in 5 and 200 ends in 0. Dividing the top by 5 gives us 5. And dividing the bottom by 5 gives us 40. And again, we can divide by 5 one more time. 5 into 5 goes once, and 5 into 40 goes 8 times. So we end up with 1/8. Okay, problem number 4. Now the difference between problem 4 and problem 1 is that the top one, 3 was in the tenths, but now 3 is in the hundredths. So whereas this one you read it as 3/10, number 4 you read this one as 3/100. Problem 5. If the whole side of the decimal is not 0, then it appears as on the left side of your mixed number. So we can write this down as 45 and 7/10. And again, that's the way it reads. Like the formal reading of this number, 45.7, is 45 and separates the whole part from the fractional part. 7/10. Same way, you read this one the same way, 45 and 7/10. Now, of course, there is the alternative approach that I don't recommend, and that one says that we can put just the whole thing on top of 10. 457, and because there is one decimal digit, that goes over 10. You could do that, but then you have to convert this into a mixed number because you have an improper fraction. So you will have to do a long division now. This time I'm not going to do the long division. You can try that. What do you mean I should try that? You try that. Okay everyone, thank you very much for watching this video, and I'll see you in the next one. And for now I will be gone in 3, 2, and 1.